The question reads, figure 6.1 shows the fuse inside the plug of a hairdryer. So this is the diagram of the fuse. We have a thin wire and we have two metal ends here, and in between these two ends a thin wire is connected. State how the fuse protects the wires in the hairdryer. So there must be some other wires in the hairdryer also, and the function of fuse is to protect them. And fuses, we know that always give the protection from the overcurrents flowing through the appliance or the device. So it protects the wires in the hairdryer by melting when the current is high. So when the current is high, the thin wire melts and breaks the circuit. So no more current can flow through the circuit. The hairdryer is rated at 240 volts. This is the rated voltage. 1500 watt. This is the rated power. It is switched on. Calculate the current. Now we have to calculate the current using the voltage and the value of power. The formula which relates all these three quantities is power is equal to voltage into current. So power is given to be 1500, voltage is given to be 240 multiplied by the current. So current is going to be equal to 1500 divided by 240 here. 6.25, which could be written as 6.3 amperes in the answer space. Suggest a suitable current rating for the fuse. So the fuse must be considerably higher than this value. So the lowest value of the fuse could be 7 amperes, or we could use it up to 12 ampere or 13 amperes too. Any value in this range of 7 to 13 amperes would work with the hairdryer. The hairdryer does not contain an earth wire to connect to the plug. State the feature of the hairdryer which ensures that it is safe to use without an earth wire. So if the earth wire is not present, then there must have been double insulation present in the hairdryer, or outside case is of plastic or rubber. That is why the earth wire is not given in the hairdryer. So this is the 1 mark answer. So any one of these two reasons would earn us 1 mark for this part. So the question ends here with this part.